This is a University of Otago podcast.
All right, so kia ora everyone. Welcome to Bite Size Science for the International Science Tellers Festival. My name is Charles. I'm a PhD student over in the zoology department, and I study honeybee brains and behaviour. So if you have any questions about that, you can certainly ask me in the breaks. Today we're going to be hearing some talks from other students and postgrads around the university who have been doing a lot of really interesting research, and so they're going to share with us what they have to do today. There'll be 10-minute talks and there'll be 5 minutes for questions, so we can hold the questions till the end, and then there'll be a little changeover time as well, so it'll be all nice and easy. And first off, we have Ashley Hinten and Damian Scarf, who are going to be talking about how we develop our sense of right and wrong.
Thank you. So as we age, we learn to tell the difference between right and wrong, good and bad, as well as the hero and the villain. This is moral development. And once we learn this, we can make social evaluations, i.e. that person did something bad, so I don't like them. There's the question of whether we're born with the ability to make social evaluations or we're taught to do so. This is called a nature versus nurture debate, and they're common in psychology. So from the nurture perspective, we learn the difference between right and wrong through rewards, punishments, and our interactions with others. So for example, if Timmy's mum gives him lollies for not teasing his little sister, he'll likely decrease his teasing in the future to get more lollies. If Sarah has one of her toys taken off of her and it upsets her, she likely won't take other people's belongings. From the nature perspective, we're born with the ability to make social evaluations. So the idea is our ancestors lived in small hunter-gatherer communities, and in order to get the resources like food, fire and water, they had to cooperate. And those who didn't cooperate weren't allowed fire, food, water, etc. So our ancestors learned to befriend those that helped and avoid those who didn't in order to survive. So if this perspective's true, and we are born with the ability, we should be able to make social evaluations without much prior experience. So looking at infants' social evaluations will give us an idea of how morality presents at birth. So the research involves recording where people look while watching events, and it's based on the violation of expectation theory. So the idea is that when we sense something unexpected or surprising, we look longer. And this is possible because human behaviour is predictable. So firstly, we're consistent. If we have a friend who consistently chooses to have tea, we'll look longer if they choose to have coffee. We're efficient. If there are 2 routes, we'll choose to take the shorter, easier route, and we'll look longer if someone takes the longer, harder route. And we're also normal. We're used to people acting with purpose, so we'd look longer if someone seemingly jumps over an obstacle when there's no obstacle there. So my supervisor has a demonstration ready to show you the type of paradigm we use.
So, what I'm going to do is I'm going to play the main character in this story, and I'm going to pass the ball to my 2 friends in the green and the blue. So, come on. It's a simple paradigm. Third time's a charm. So, now, if I had a choice of who I would play with, who do you think I would pick? Would I pick the guy in the green or the girl in the blue? Blue, exactly. So, if I went over and I hung out with the boy in the green, this would violate your expectations. So you'd be surprised that I'm approaching the person that was mean, not very nice, and although was my student, is clearly not helping us with this talk. So this is the same kind of paradigm that we use with infants. But instead of asking them, because obviously they can't tell us who we should hang out with, we rely on their looking time. So they'll look longer to things that don't fit with what they expect. So if I walk over to Ben, they'll look longer at this than they would if I walked over to the person that helped. So that is how we test violation of expectation.
So babies and infants obviously can't tell us what they think about individuals. They don't have the language ability. So like we just talked about, we have to look at their looking behaviour. So we do this while they watch puppet shows or animations of characters interacting. The eye tracking technology has developed substantially to head-worn designs and even simple glasses like the top left there, but the type we used was built into a monitor, so that's the bottom left. As long as the viewer is high enough and close enough to the monitor, it can record where they're looking. On the right is some examples of how you can present the data. So the top one is called a heat map, and it's a colour representation of where they looked the most. So red is where they looked the most, followed by orange, then yellow, then green, and the blank or transparent areas where you can still see the image is where they didn't look at all. The bottom one is called a gaze plot. So each colour represents a different viewer, and the circles are where they fixated for a certain amount of time. So these are numbered and joined, so you can trace exactly where they were looking and in what pattern. So one set of animations used is called the hill paradigm. So I have the video clips here to show you. This is the help event. So the circle easily gets up the first slope, but they struggle up the second, bigger, steeper slope, and the triangle comes down and helps them to the top of the hill. The hinder event is similar, except that when they go to do the second slope, they're not helped to the top. The square comes down and pushes them to the bottom of the hill. So who do you guys think the circle would want to approach? Who thinks they'd approach the square? And who thinks they'd approach the triangle? Yeah, so you all say the triangle. So let's see what the circle decides to do. So that circle actually approached the square, the hinderer. So the idea for violation of the expectation is that we'd be surprised they approach the bad guy and we'd look longer. So what has the research found? These graphs all have mean looking time in seconds on the y-axis, and the blue bar is the helper approach, and the yellow bar is the hinderer approach. So the researchers that made the paradigm, Kohlmeyer and colleagues, found their 12-month-old participants looked longer when the helper was approached. This isn't what violation of expectation theory predicts. You'd expect them to approach the helper, so you wouldn't be surprised and you wouldn't look longer. They thought that maybe they looked longer when the helper was approached just because they liked the helper better. However, when Hamlin and colleagues did the study, they found longer looking time when the hinderer was approached. And that's what we expect for violation of expectation theory. You would expect them to approach their helper, so you'd be surprised they approach the hinderer and you'd look longer. So my supervisor, Damian, and I wanted to see if we could repeat one of these results, because obviously they're different. Our 16 and 34-month-olds looked equally no matter who was approached. And when they were asked who the circle would want to be friends with, they weren't more likely to choose the helper. So replication is a core idea in science. We want to make sure the results are reliable and generalizable. So this means that we do the study with a small group of children, and we want to see if the results would hold for other children or a larger group of children. So this might seem uninteresting, or it might struggle to gain funding, but I think the social evaluation research is a great example of why replication is so important. So there are three main potential reasons for why we didn't repeat the same results as the other studies. First, liking the helper and being surprised the hinderer was approached aren't mutually exclusive. So these could be happening at the same time, washing out any effects. So that's why we could have got equal looking to the helper and the hinderer approach. Secondly, when children were asked why the circle would want to befriend their chosen character, a few children said that it's good to be friends. And after the experiment, their parents would repeat this to them. So the idea is that they might have been taught forgiveness norms by their parents or teachers or other adults in their life. So it's sort of the concept that Timmy might have hit you while you were playing in the playground, but you should still be friends. And thirdly, there could be a lab effect, where researchers have small differences in how they carry out the paradigms. So when they write a journal article, they have a word limit they have to stick to, and they might leave out details that they don't think are important, like sound effects, background music, or the script of how they ask the children the questions. So the idea is that these little effects might actually be important and influence the results. So overall, it would seem that moral development and social evaluations are developed through nurture and not nature, especially with the forgiveness norms idea. So this year I'm continuing the research with looking times and also seeing their likelihood to help. So while we're carrying in, I knock over crayons and see if they help me and how long it takes them to do so. And I'm also interested in the idea of consistency. So in real life, people aren't 100% good or 100% bad. And I'm interested in how that would affect social evaluations and looking time. So while the results might be confusing and there's a lot more to study, it's clear morality is not black and white. Thank you.
Cool. Thanks for that. That was interesting. Does anyone have any questions about that? Oh, yeah.
Just a quick question. I noticed in your results that in your study, the children actually looked for much shorter time compared to the other studies. Any explanations for that?
We showed them one 5-minute clip for the approach, whereas the other studies showed them the clip over and over again until they looked for a certain amount of time.
So are you planning, maybe when you're looking into replicating the results or seeing what the other studies have done, are you planning to complete some, do the experiment in a similar way of actually giving them the same clip multiple times?
Yeah, we could try that. At the moment, we're just showing them one clip because that's what most of the studies have done, but we could definitely try it, yeah.
Great, thank you.
No worries.
Cool. I have a question, though. Between the 2003 and 2007 study, were there any key differences, like in the model they used or age of child? Like, do you think there's a switching point or a defining point where there's a certain bias in the child?
Well, the coal miner study had 12-month-old participants, and the Hamlin study had 10-month-old participants. So they were quite close in age, and I'm not sure there are any obvious method differences that I can remember.
Oh, interesting.
Yeah.
And so you are using much older children.
Yeah.
Do you think that would be making it more difficult because they're a bit more of a complex study?
Yeah, so you think they might have been exposed to more norms by then, and it might be, more complex. Maybe, yeah, we do have 16-month-olds and 34-month-olds. It was mainly to be able to ask them the verbal questions, because obviously 10-month-olds and 12-month-olds can't really tell us, so, yeah.
Cool, awesome, thank you.